Hi there. What I want to do now is to just do an example question for projectile motion. So the example question is simply a projectile that's fired at an angle. Let's say that the angle is 30 degrees from the horizontal. Let's give it a velocity of 200 meters per second. And let's calculate a couple of things. Let's calculate the maximum height that's been reached. And then we'll do the time of flight and the range, but let's deal with the max height first. So to deal with how high this will go, we need to use the equations of motion. And what I will do is always start with suva, and then writing down which direction we are taking as positive. So we want the maximum height, so we're working vertically. We will take up as positive, and then we'll put some numbers in. So the maximum vertical displacement is what we're looking for. The maximum height, we'll call that S. The speed, we need the vertical component of this speed. So you can use trigonometry. But what you should find is that the vertical component of that speed is 200 times sine 30. Sine 30 is a half, so 200 times a half is 100 meters per second. The final velocity, well, the velocity at the maximum height vertically would be 0. The acceleration due to gravity, which acts down, is minus 9.81 meters per second squared. And t is what we're looking for in the second question. But for now, we're not interested. So you could put an x there if you wished. So we need an equation. There's no t. So an equation without t would be v squared equals u squared plus 2as. Then we just need to rearrange to find s. So v squared minus u squared divided by 2a, v squared minus u squared over 2a, will give us the vertical displacement. So that would be 0 squared minus 100 squared divided by 2 times minus 9.81. So we can simply say 100 squared divided by 19.62. The minuses will cancel out. And that will give us the vertical displacement. So if you wish to get your calculator, just to check, so 100 squared divided by 19.62. So that will give us a maximum vertical height, S, equal to 510 meters. So the next thing we're going to do, so same again, 200 meters per second, 30 degrees from the horizontal. We're going to calculate the time of flight. So what we need to do is calculate how long it takes for the object to reach the maximum height. And then we can just simply times it by 2, because the amount of time it takes to reach the maximum height is the amount of time it will take to fall the equivalent distance. So we're going to do suva again. We'll take up as positive. Displacement we found out is 510 meters. The initial speed is, yet again, 200 times sine 30, which is 100 meters per second. The final velocity at the maximum height will be 0. The acceleration again is minus 9.81 meters per second squared. And t is what we're looking for. So in this instance, we can simply use v equals u plus at and rearrange to get time. So time is equal to v minus u divided by a. So v is 0, so it's minus 100 divided by minus 9.81. So if you put that into your calculator, you'll get 10.19 seconds, or 10.2, which should be suffice. So the time is 10.2. That is the amount of time it takes to hit the maximum height. So we have to times that by 2 to get the time of flight. So that will give us a total time of 20.4 seconds. So we've got the time of flight now. It's 20.4 seconds. The final question, remember to pause this to attempt the questions. So I'll write it out, 200 meters per second, 30 degrees from the horizontal. Now we're going to find the range. So the object is going to follow this parabola. The range is the distance horizontally. Again, to do that, I'm just going to move this image. We need to do suvat, but this time we're going to do suvat horizontally. So take to the right as positive. And you'll find something interesting occur here. So the displacement S is what we're looking for. The initial speed, if we look at our triangle, is this horizontal component, which is 200 times cos 30, just using trigonometry. The final velocity horizontally, just the instantaneously before it hits the ground, the surface, is the same, is 200 times cos 30. Because at low speeds we can ignore air resistance, and at A level you typically will definitely ignore air resistance. So you see that the acceleration horizontally is 0 meters per second squared. There is none. And the time of flight is 20.4 seconds. So if we were going to use an equation of motion, it would be S equals ut plus half at squared. Sorry about that. But the acceleration is equal to 0, so the half at squared all collapses. And we're just left with simply displacement is speed times time, so S equals ut. So the displacement is simply the horizontal speed, which is 200 cos 30, times the time of flight, which is 20.4. When you get used to these, you won't have to do this long convoluted process. You'll just straight away you'll know that S equals ut for horizontal as we ignore air resistance. So 200 cos 30 times 20.4. So the range is 3,533 meters. Thank you for listening.